Hi, in this video we'll show you how to change basic LUN configuration options when using the SANBlaze VirtuaLUN in target mode. To access the LUN configuration page, simply click on the LUN you want to modify from the left-hand menu. Once you do that, you're presented with this LUN configuration page. This page allows you to change basic parameters that describe the given LUN. You can start by changing vendor ID, product ID, and revision information. By default, the LUN would show up as a SANBlaze LUN, but you can change this to say any other vendor you want, and this is what would be presented to the host. You can change the size of the LUN, the read size here. Currently the LUN is bound by the amount of free memory that's left in the box, in this case 1.7 gig. So I can make the LUN up to that size in megabytes. There's another mode of operation where I can unlock the read size from the write size. What this lets me do is, if I check that and hit apply, is now I can create a LUN that will look much larger to the host, all the way up to 100 terabytes in size. Under that, you can give it some amount of writable space, let's say a gigabyte that's still bound by memory. What this lets you do is present a large drive to a OS, let's say, and give it enough space to initialize the drive and format it without corrupting data. If you exceed the write size, the writes will begin to get thrown away. They'll still get responded to with good status, but the data would be corrupted, so you can't do any data integrity testing. But this would be more for doing large LUN addressing testing. There's a third mode of size operation called bind to file. What this lets you do is, instead of using system memory to write your LUN data to, you can create a file on the hard drive in the unit and write to that. This will allow you to have much larger drives that won't corrupt data. However, they're going to be a lot slower, since you have to write to a physical disk now instead of memory. A few more options you can set. You can set latency, for read latency, write latency. You can give it a range here, a minimum and a maximum. And when a read or write comes in, it'll randomly assign a latency to the I/O based on the values inputted here to simulate, seek time of a real device. Or you could add latency based on the size of the I/O coming in. So larger reads or writes would be slower than smaller ones. Marking a drive enabled simply takes it offline. All the data is still intact, however it'll stop responding until you mark it exists again. Turn off or on write enabled for the drive, ready, not ready. You can assign a LUN number. Right now this is LUN 0. However, I could make this LUN present itself to the host as a different LUN ID. So let's say I want to make it look like LUN 16. I can put a 16 in there and hit apply. It's a way to test sparse LUN IDs on the host side. Finally, any data you'd written to the drive you could save to a file. So let's say I had formatted this LUN, I could save that data off to a file, and then I could restore it to any other LUN at any given time. Also on this page you can get per LUN performance information here, current number of IOs, and throughput information. Finally, the scope column allows you to make changes across multiple LUNs in the unit at the same time. You can simply check off which items you want to apply the scope to. Let's say I want to change the version number. Once I do that, at the bottom you can specify the scope of the changes. So I could say apply this change to all LUNs, on all targets, on all ports, and hit apply. So we'll quickly make changes to the entire system at once, so you don't have to click on every single LUN to make the same change.